Welcome, this is 8.5, Properties of Logarithms. In this section we're going to continue what we've been learning with logarithms, only we're going to learn some specific properties that let us change a logarithmic statement, and we use this to simplify. I'll say more later, but there's a few properties that we're going to learn to start off with. The first one is called the product property. The product property. And I want to remind you of the product property we had when we were doing exponents. So remember from your past in chapter 7 when I had something like x to the m times x to the n. In chapter 7, remember, we added the exponents. Now I've been saying this a lot lately, but logarithms are the inverses of exponents. So what happens with a log is very similar to what happens with the exponent because they are related. They're inverses of each other. So here, if I had a multiply between my things, I actually add the exponents. When I have a log, here's what this looks like. Let's say I have log base a of u times v. That is the same thing as doing log base a of u plus log base a of v. So I split them up and they each got their own log. The next one you're going to learn about is called the quotient property. This one matches with what we learned with something like x to the m divided by x to the n. Remember we subtracted the exponents? So here's what our quotient property says. Let's say I have a fraction, log base a of u divided by v. That is the same thing as doing log base a of u subtract log base a of v. And last but not least, we have something that I call the power property, but it's not really an official name. Here's what the power property says. Let's say I have log base a of u to the nth power. So this thing here has an exponent. I can take the exponent and put it in front and say n times log base a of u, and it is equivalent. So those are the three properties that we're going to use. We're going to use these to simplify expressions, and we're going to use these to do something called expanding and condensing some logarithms. So we're not really solving anything today, we're just changing the format and trying to find a numerical answer in some situations. Let's look at example 1. It says use the properties of logarithms to approximate each. And we know that log base 5 of 3 is approximately 0.683 and log base 5 of 7 is approximately 1.209. Alright, you're going to be given some statement. In this part right here, they have used a 3 and a 7 in some way, and then we're going to think about the properties of logs. So in this situation, what they've done is they've given us a fraction, so I can first split this up into log base 5 of 3 minus log base 5 of 7 using the quotient property we learned. So just notice that the base was 5 instead of a, and then 3 and 7 instead of u and v. Alright, now the reason I wanted to split it up this way is because I know these, they were given to us, and this is the way I can do this without even using a calculator. And I'm just using the information they gave me up there. So I've got 0.683 subtract 1.209, so my answer for that statement is approximately negative 0.526. Part B. Now I need to think of the number 21. How is the number 21 related to 3 and 7 is what I'm asking myself. And hopefully you can see that the number 21 is related in that it is 3 times 7. So when I rewrite it as log base 5 of 3 times 7, now it matches with my product property. So now it matches with my property that I can split this up into log base 5 of 3 plus log base 5 of 7. And this is equal to this. If we're going to learn at the end of this lesson actually now how to put these into your calculator. But if I put the first thing into my calculator and the second thing, I'd get the same answer. Alright, let's keep going. Now I'm going to put what I know the decimal approximation to be, so 0.683 plus 1.209. And so this is approximately 1.2773. Last but not least, part C. So I got log base 5 of 49. Again, think of how that is related to 3 and 7. And in this situation, actually, there's no 3 involved. It's just log base 5 of 7 times 7. So that's going to happen sometimes. So this one ends up being log base 5 of 7 plus log base 5 of 7. And log base 5 of 7 is 1.209 approximately from what we got there. So here's what I've got. And my answer then, add them together, is approximately 2.418. All right, your turn. So at this time I want you to pause the video and try D, E, and F, and when you unpause, I'll have the answers showing, and then we can go over these in class more if you need to. All right, here are the answers for D, E, and F. How'd you do? Hopefully pretty well. Let's move on to example 2. Now we're going to use some of our properties in a little bit of a different way, but we're going to still be using our properties to evaluate without a calculator. So here's what I've got. Part A, I've got log base 3 of 9 squared. All right, here's what I want you to think about. Log base 3 of 9 squared, well, I just taught you that whenever I have an exponent, I can move that to the front, and that's not always going to be our first step that we want to take. It does work in this situation, and the reason it works in this situation is because in my mind I was kind of thinking, hey, I know how to find log base 3 of 9 without a calculator. Now review from our previous sections. Log base 3 of 9, to figure out what this answer is, we're trying to figure out what power of 3 gives us 9, and whatever goes in this box is what this whole thing is equivalent to. So this is an easy one because I hope you can see 3 squared is 9. So this entire log statement is just equal to 2, and I'm just going to carry down the 2 from before, so now 2 times 2 is 4. Alright, let's do the next one. In this situation, I could multiply them together, but I see that they're separated, so in my mind I'm thinking, well, they probably did that because they want me to use one of my log properties. So I look back to my properties, I see it looks the most like the product property, so I'm going to split this up into log base 5 of 5 plus log base 5 of 125. Notice that whenever I'm splitting these, every single time, each piece gets its own log base 5 or log base whatever, so each piece is going to get its own. And now we're going to try to do each of these separately without a calculator. So again, every single time I'm trying to figure out what power of the base gives me the big number. So first I have 5 box equals 5, so that's just going to be equal to 1, or you may have remembered as well that if I have the base and this number the same, it's always equal to 1. But okay, anyways, here for this one I'm trying to figure out what power of 5 gives us 125. Do a little guess and check if needed. It ends up being 3. So my final answer for B is also 4. Alright, look at part C. So in this situation, again, I'm kind of thinking that I would like to take this 5 and carry it down. And in this situation, it actually will work if we distribute the 5 as well, but we'll try it this way. Alright, here's what I've got to start off with. I am seeing that I have a fraction right here, so in my mind I'm thinking the quotient property. And now watch this, that 5 was in front of this entire log statement, so when I split the log statement up, the 5 needs to go with both of them. So to make that happen, I put this whole thing in parentheses. So then 5 will be multiplied by what the whole answer that's in this parentheses then. Alright, so now again I've got some log statements to solve. So this one I'm thinking, okay, what power of 4 gives me 1? And this one I'm thinking, what power of 4 gives me 4? Alright, remember, this is both of these are special situations this time actually. And whenever I've got 1 for my answer, the only way I can make that happen is if it's 0. So the answer to that is just 0. And then whenever I have these two things the same, well, the only way I can get a 4 back again is if it's 1. Still have the 5 there. Alright, but 0 minus 1 is negative 1, so 5 times negative 1. 5 times negative 1. There I go. I threw this last one in here because I wanted to show you that, remember, a ln log is the same thing as a normal log, so same rules apply. So if I look at this ln log, I first see that it has a fraction bar, so same rules apply. The quotient property applies. I got ln of 3 subtract ln of e cubed. Next, this part, as of right now, we can't actually simplify that unless we do use our calculator. So I'll just leave it as ln of 3. And then over here I put in the base so that you could see what's happening here. Remember, if you have the base and this number the same, it's just equal to the exponent. Well, now we know this property as well, where I bring the exponent into the front. This part is equal to 1. So really what I've got is the natural log of 3 subtract 3. Make sure that if you have any questions on this section, you write them down or make note of it, because I'm guessing some of these we're going to want to work through the next day in class. Let's move on to expanding though. So one of our goals here with these properties is to make our log statements we're usually using the log properties to condense them because that would be what we'd want to do in a problem situation, but we're going to also practice going the other way, which is expanding logs. Here's what I mean. When I'm expanding, my goal is to make it so that every single piece that I have in my log statement has its own log, and every number and variable counts as its own piece, except the base. The base just goes with the log every time, so that we don't worry about. Alright, so if you want to, when I'm trying to expand, I can do this one step at a time, or I could do it all at once. Let me show you a little bit of both. So first of all, I've got 7x cubed on top. It's like 7 times x cubed. So in my mind immediately I'm thinking, okay, log base 2 of 7 plus log base 2 of x cubed using my quotient property. And then all of those are divided by y, so that is going to end up being log base 2 subtract log base 2 of y. Now notice, this is what I meant when I said each one of these pieces to start off with gets its own log, and the 2 just sticks with the log, so don't worry about the base. And here's a shortcut. When I'm expanding, anything on top is positive down here. Anything on bottom is going to be negative, and I'll say more about that later, but the reason is because of the quotient property. In the property I only showed you one thing on bottom, but if I had more things on bottom, all of them would be negative. Alright, last but not least, to fully have something expanded, I don't want an exponent, so I'm going to move that exponent to the front of the log for this middle statement. All the other ones stay the same, and then I'm done. So you might want to make a note to yourself. This is very unofficial, but every piece gets its own log. Also, we don't want any exponents when I'm expanding. And I want to point out that we haven't actually solved for anything. All we've done is kind of move stuff around. So that's sometimes what throws students off, is that it may seem like we haven't really done anything because all we're doing is changing what it looks like. Let's do part B next. Alright, notice how this time, when I have 2x to the 6, it really means 2 times x to the 6th, right? So the reason that's significant is because that means that I can use my product property. This means I have log of 2 plus log of x to the 6th. And notice that these ones don't have a base. So again, whatever the starting base is, you just keep it the same all the way through. This one doesn't have a base, so remember that means it's a common logarithm, so it'd be really base 10. Last but not least in this problem though, I need to move that exponent to the front. So I got 6 times log of the x and then log of 2, and that is it for my final answer. That's it for this video, so tune into the next one for the rest of these